How does puberty affect teenagers' brains? Have you ever wondered why teenagers can seem so different from their younger selves? The answer lies in the fascinating changes happening in their brains during puberty. So, how does puberty affect teenagers' brains? During this time, teenagers experience a remarkable transformation driven by hormonal changes. The rise in sex hormones like testosterone and estrogen not only leads to physical changes, but also impacts brain development. These hormones act on specific areas of the brain that are rich in hormone receptors, causing significant reorganization. This is a second major phase of brain development that builds on earlier stages and permanently reshapes neural networks. Interestingly, these hormones affect boys and girls differently. Testosterone in boys tends to reduce the releases of stress hormones, making them a bit more resilient to stress. On the other hand, estrogen in girls can increase sensitivity to stress. This hormonal adjustment alters the brain's stress response system in surprising ways. Structurally, the teenage brain goes through a pruning process, cutting away more than 40% of synapses, which are the connections between neurons. This pruning mainly occurs in the frontal lobes, the areas responsible for decision-making and impulse control. At the same time, the brain's white matter continues to develop. White matter insulates nerve fibers, speeding up communication between different parts of the brain. The corpus callosum, which connects the brains to hemispheres, thickens with white matter, improving coordination. Another quirky aspect of puberty is the rewiring of the brain's reward system. The connection between the prefrontal cortex and the midbrain reward centers is still developing. This partly explains why teenagers are more sensitive to new and exciting experiences. It also makes them more vulnerable to addictions, such as nicotine, at lower doses than adults. Chemically, neurotransmitters like dopamine, serotonin, glutamate, and gamma-aminobutyric acid are in flux during this time. For instance, lower levels of gamma-aminobutyric acid, which is an inhibitory neurotransmitter, may lead to intense emotions and less impulse control in teenagers. Research with animals shows that fear memories learned during adolescence are harder to erase, indicating that emotional learning is wired differently at this stage. Puberty also shifts teenagers' internal clocks, making them naturally inclined to stay up late and struggle with early mornings. This biological change can clash with typical school schedules, adding another layer to the teenage experience. From the perspective of weird science, puberty turns the teenage brain into a unique laboratory of change. Hormones act like chemical puppeteers, synapses are cut and rewired, neurotransmitters play tug-of-war, and the brain's reward system creates a roller coaster of sensations. This transformation leads to quirky and unpredictable behaviors that are part of the fascinating journey from childhood to adulthood.